NASA's spacecraft dedicated to studying the Sun is called Parker Solar Probe. Launched on 12 August 2018, this mission is the closest a spacecraft has ever gone to the Sun. Key facts about Parker Solar Probe. Objective: to get closer to the Sun than any previous spacecraft and gather data about the Sun's outer atmosphere, corona, solar wind and coronal mass ejections. Distance: the spacecraft will pass within 4 million miles of the Sun's surface, much closer than Mercury, which orbits about 36 million miles from the Sun, which is more than 7 times closer than the previous record holder, the Helios spacecraft. Mission goals: to study the Sun's magnetic fields, solar winds, and the mechanisms behind solar flares and coronal mass ejections. Understanding these phenomena can improve predictions of space weather, which can affect Earth's communications, satellites, and power grids. Mission duration: ongoing, with an expected duration of about 7 years. Heat shield: the probe is equipped with a revolutionary heat shield thermal protection system, TPS, made of carbon composite materials. Parker Solar Probe is equipped with a cutting-edge heat shield called Whisper, wide-field imager for Parker Solar Probe, that can withstand temperatures up to 2,500 degrees Fahrenheit, 1,377 degrees Celsius, protecting its instruments from the Sun's intense heat and ensuring the spacecraft can operate in extreme conditions. Scientific goals. Solar wind: the probe aims to understand the origin of solar wind, the stream of charged particles emitted by the Sun, and how it accelerates. Magnetic fields: by studying the Sun's magnetic fields, Parker Solar Probe will help scientists understand how these fields drive solar activity, such as flares and coronal mass ejections. Coronal heating: one of the long-standing mysteries in solar science is why the Sun's outer atmosphere, the corona, is much hotter than its surface. Parker will gather data to help answer this question. Instruments: the spacecraft carries 4 scientific instruments designed to measure electric and magnetic fields, plasma waves, and energetic particles around the Sun. Fields: measures electric and magnetic fields. Whisper: a wide-field imaging instrument that captures solar wind and coronal structures. Sweep: measures solar wind particles like electrons, protons, and ions. ISOIS: measures high-energy solar particles. Mission achievements. First closest approach. In 2019, Parker Solar Probe completed its first close flyby of the Sun, bringing it to about 15 million miles, 24 million kilometers, from the Sun's surface. It is gradually getting closer with each orbit. Heliophysics research. Its data is enhancing our understanding of space weather, which can affect satellite operations, communications, and power systems on Earth. Future objectives. As it continues its orbits, Parker Solar Probe will get even closer to the Sun, each time coming within a few million miles of its surface. It will continue to send back data throughout its mission, helping scientists answer fundamental questions about the Sun's behavior and its influence on the solar system. Parker Solar Probe has already made several close approaches to the Sun and continues to transmit valuable data back to Earth.